So that was about linear search. What is the advantage? Advantage is easy to understand, easy to implement, right? Implementation is also easy. Fine. But what is disadvantage? Disadvantage is if the array is big, it will take more time on comparing values which are not the item which we are searching. So somebody will ask you in interview, why linear search is bad? So you have to explain it that if array is big, it will take time to compare the values which we are not finding. We are finding something which is present at the end, let's say. So there are three cases. There is a best case, worst case, and average case. Okay. What is the best case in linear search? That the number which you are searching is present at the first index. It's a best case. So if you're searching 12, it's perfect. You are searching, a number which is present at the 0th index, then and there you found it, you come out of the loop and done. Very fast. But a number, let's say if you're searching 9, then unnecessarily we are comparing till this, and at the end we find it, okay, it's present here. Okay. So best case is when the number is found at 0th index. Worst case, when the number is present at the number which we are searching is present at last index. Okay. Average case, okay, we will take it. Okay, average, it will take. So for example, there are eight values, right? So probably let's say we will take, okay, maybe it will take, four comparison to get the number. But this is when you are lucky, right? If you are lucky, you will be able to find it, within four comparison, something like that. So that's why there is a problem in this. There is a disadvantage. You never know if you have the number, at the lower side, like in the higher indexes, correct? That's why binary search is invented. Binary search is faster than linear search, right? But how it is faster? Let's understand that thing. But there is a limitation. So there is a prerequisite for the binary search. Prerequisite. What is the prerequisite? Is array should be in sorted manner. It should be sorted, then only it will work. So you cannot apply binary search in this. You should get it sorted first either, or assume that it is already sorted. So let me put the values here. So basically 3 will come here. What is the next highest value is 9. Then I think 12, 15, 17, 23, 56, 78. So let's assume this is our array now. Okay. Let me make the color coding here. So let's assume this is our array. Same thing. And it has these indexes. So let me copy this. These will be the indexes. and this is the whole number array. Okay. Somebody is asking, in real life search engine, how does searching for item works in server layer? Generally, they implement binary search, okay, or mix of different searching pattern. Okay, fine. Because this is faster, I'll tell you how it is faster. So what is the logic behind binary search is, it's like search from middle. So the first rule is search from middle. Search from middle index, because we don't know what is present at the middle. So don't assume that you know all the numbers. Searching means you don't know any number. You are searching through indexes. Okay, fine. So search from middle. So I'm telling you very simple logic. If somebody will ask you how binary search works, you have to explain this way. Binary search is a method where we start searching from the middle index. Okay, that means we divide the array in two parts. The value which is present at the right side of the, so let me present this, the whole thing in, let me copy it. Basically, I should present it in, let me check if it's possible or not. It's possible to transpose, right? Yes, I was checking this. So basically, just done that. My bad. So this is done. Now I just want to color code it. Okay. So this is our array. 0th index value 3, first index 9. So now you have to divide it in two parts. So you will say this is my middle. This is my mid. Let me color it. So this is my middle. What we will do, we'll check whether the value is present at the middle index. If the value is greater than the value present at the mid, so let's say this is mid, this is min. We are just, or start. We'll get the name as a start index. This is end index and this is mid index. So we'll check whether the value which we are searching is present at the mid index. If it is present at the mid index, good and well and good. And we'll also check whether the value which we are searching is greater than the value present at the mid index. If it is greater, then don't do anything here. Correct? Don't waste your time to search something in this. Right? It's same as if I tell you that in a book, you have to find a picture. Okay. And if I can tell you that picture is present at the 78th page and the book is of 50 pages, the book is of 100 pages. If I tell you that the picture in a book is present at the 78th page, or the second half of the page of the book, so what you will do, you will just neglect this, right? You will just neglect the first half, means the first 50 pages, will you search it, that picture? If I tell you that the picture is present at the second half of the book, so you will start searching from the 51st page to the 100th page, correct? Because in the same way, what we will do is we'll start from the mid. We'll check, hey, if our value is present, what we are searching is present at mid, well and good. If it is not present, if the value which we are searching is greater than the value present at mid, then increase the value of mid, increase the value of, sorry, increase the value of start. So new start will be this. Okay. And we will concentrate only this part now. Okay. Again, we will calculate the mid. What will the mid of these four values? So we'll consider this will as a new mid. Okay, we'll consider that this is our mid. Now again we will check. So I'll give you real example. Let's assume I'm deleting this first because this is important to understand first. Let's understand. I am searching the value 56. Let's assume the searching item is 56, not 50. So how we will do? We'll we will say our start. So we have to declare our start index is 0, index is 7. Mid index is 0 plus 7 divided by 2, which is 3. 3.5, but we will take only the floor value. So that is 3. We'll check. So what code we will write? We will say if searching item is greater than is greater than um, array items, whatever the name of roll number, right? We have given roll number. The roll number of mid. Then what we will do, we'll say, hey, start should be mid plus 1. Now our start index should be 4, not 0, because the value which you are searching, 56, is present after the mid. It is present after the mid. This 56 is present after the mid. So why to waste our time to search here? Let's make our start here. So what we will say? Hey, our new start will be mid plus 1. We are talking about the indexes, not the values. Again, there is another if the searching item is what you are searching is less than the roll number, whatever is this. So another example is like this. What we are doing here, we are saying, let's assume that we are searching for 9, not 56. So what will happen? The number at the mid, which is present 15, and what you are searching 9, which is less than 15. So don't waste your time to search here, right? Keep start as it is. Now make a new end. End will be mid minus 1. So present mid is 3. So what you will say? Hey, now change the end. End will be mid minus 1. So this is the logic, main logic behind binary search. And always create a new mid. So mid will be start plus end divided by 2. Okay. So it will keep on doing the same thing until start, till the point start is, what do we say, greater than end. So there will be a situation when start and end will become same. Okay, start, end, and the mid will become same, and automatically your number which you are searching will come at mid position. So that's the beauty of binary search, that I'm repeating it. The number which you are searching will automatically come at the mid position. This is the bigger example. Let me give you very simple one, just 5 value example. Okay, let me take 3, 5, 9, 13, 14, just 5 values. Okay, I'll play with this 5 values only. Okay, let's understand this. Now this is my start, which is like 3. Index, so start is means 0 index, not the value. Okay, and this is as of now my end. Okay, which is end is equals to 4 index wise, and this is like start is equals to 0th index. Correct? Clear? Now let's assume we are searching number 3. We are searching the number 3, and as of now this mid is equals to 2. Mathematical calculation and all we will do it later on. First understand the logic behind the binary search. So what we do, start index is 0, end index is 4, okay, mid is 2. Mid will always be 0 plus start plus end divided by 2. You will search, hey, my number is present at the mid. No. Then you will check, hey, my number is less than the value present at the mid. Yes. You are searching 3, let's assume. So what you will do is, if the number which you are searching is less than the number which is present at mid, you will say, I want to change my end position. Now, this will not be my end position. My end position will be this. So you'll say my end will be mid minus 1. So end will become 1. Okay. That's it. Now, again, same thing will happen because we are on loop. Start plus end divided by 2, which this will be mid. So 0 plus 1 divided by 2, which will be 0.5, which will be actually 0. We will take the floor values. Now, see, automatically, now the next check will be, hey, so this will become mid. Again, understand it. 0 plus 1 divided by 2, 0 plus 1 divided by 2, which will be our new mid. Mid is equals to this. And that will be basically mid will become 0. Now you will check the whether my number is present at the mid. Yes. So just two search, two comparison, and you are done. Right? Same thing will happen if it is the number which you are searching at the end also. Just two comparison. Whereas in the linear search, it was taking 5 comparison to find it whether a number is present in this 5 value array or not. But in the binary search, it's log of n, right? So there is one logic about um, how much, you know, the complexity, time complexity of this program is log of n. N means the how many numbers are there, right? So let's implement it. I don't want to waste the time on writing the whole code. I know there is a website where this code is written. I'll copy it. Same thing, whatever I have explained you, same thing, I'm taking it from here. Done. Let me put it in the program. So this thing, we did it in linear search. We'll copy the same thing. Let me copy the whole code first. Copying it, let's create a new program. 15th number code for binary search.js. Paste it. And what are the changes we will do in this program? Let me write that part. Okay. Let me do some changes. So length of array is fine. Instead of length, let's take it end index. Sorry, end will be this length. Start, let's take the start. So searching item is fine. So searching item is fine. I'll not change it. Is found is also fine. Is found. Okay, let's keep it. Then we are saying console.log, that's fine. Index, instead of index, let's take mid. And let's write the code now, the real code which you want. I'm deleting all this part. Okay. So this is the basic thing we have as of now for our program. And let me copy this and going back to this. So it's saying what is our start? Start I have declared, right? Start I have not declared. Start is equals to 0. That's fine. Mid is equals to 0 as of now. That is also fine. End will be, so my bad. So what we will do, end will be length minus 1, not because we are playing with the indexes. Done. So while start is less than equal to end, do the same thing. Let mid is equals to start plus end divided by 2. You may be asking, what is this math.floor? So math.floor is a function which will get the floor value. Okay? Read about it. Floor value means when you say 0.7, so the floor value is 0. When you say 3.7 or 3.5, the floor value is 3 and the seal value is 4. Okay, I just read about what is floor and what is seal, those things. Okay, you can use parse int also. Instead of using math.floor, you can use parse int also. Start plus end divided by 2. Yes. Then we are checking whether the number is present at the middle, then return true. So this is like a function. We don't have to do it. Let's do it in our own way. What we will do, instead of this, we'll write if this is true, then is found, make it true. That will be a better way. Okay. Is found is true and break it. Break means come out of the things. Okay. Else if yeah, this I have already talked about. Else, so you can after the else you can put again if, okay, because you want to put another condition. So okay, the array name is not ARR. Array name is roll numbers. Okay. Our array name is roll numbers. So I'll put it like roll numbers of mid. Okay, that's it. So if it's less than, okay, instead of X, we'll write search item, searching item, because we are comparing with the searching item. Done. Okay, if that is the case, make the start as mid one, else make end is equals to mid minus one. Done. You don't have to write return and all. Done the code. But one thing which we have to do, same as like this, we will check is found is true or false, and then based on that we'll say it's found or not. Done. Same code. So same thing, but it's somehow a bit logical. Somehow you have to do a dry run to understand it, but it's very good, very smart thing to do the searching in binary search way. Okay. And why the name is binary search? Because you're searching from both the ways. It's not like just from the start or from the end. It's like you're searching in two different parts, right? Either maybe the right hand side of the middle or the left hand side of the middle. That is why it's called binary search. Okay. That's it. Let's run this program. Okay. And clear, and we'll run node dot slash 15. Okay, fine search done. Oh, there is an error. Maybe um we are in hurry, so I did some mistake. Let me check. Let's start this. End, mid, all good. Mm, Line number 19. This equal to sign. 3 times I have done. That part you are saying. That should be fine, but I made it 3 times now. So if this is this, do this thing. Okay, let's run this again. Going back to the terminal. No, it's at invalid parameter, but it's not saying where. Just a bit. It's saying about the parameter part. Give me one minute. Roll number is fine. End is fine. Searching item is fine. Is found is equals to false. Okay. Console.log 8. Just a minute. Start is 0. Okay. We are saying start. This is our start of this while. end of the while is done, and if else. All things look good to me. Then there is a code mid is equals to math dot floor and something here. Oh, maybe you're saying I'm not executing in the right way. Okay, let me check that part also. Hmm. I'm writing mode. Actually, I should write node. Okay, my bad. Spelling mistake. But now it's saying me. It's at line number 7. Anonymous object I'm creating. Length of array is not defined. Good one. So line number 7. Length of array. Yeah, there is nothing like that. Earlier we were using it. It's end now. So let me delete this line. This is not required. And we will run it again. Okay. Clear. CLEAR. And let's run this again. It's saying not found because we were searching 40. Now let's search 78 and it will say me found this time. Oh, still not found. Superb. Searching item is 78. 78 is present here. Let me check if else. Found it, not found. Is found is equals to true. Did I made is found is equals to true? When I find it, I made it. When the roll number of mid is equals to searching item, then do that thing. Okay, we did it. And earlier is found was false. Let me run it again. Give me 1 minute. Clear. Let me save this. Let's run it again. Just a minute. There is some problem at my system. Saving it again. Let me open the terminal and node. It's not allowing me to write anything. Let me give. Let me just open new terminal. I'll say node dot slash 15 final search. Not found. What is the number we are searching? 78, right? Which is present here. So I'm checking what is happening. The start is less than equal to end. Yes. And we are checking mid is equals to math dot floor. Okay. Roll number of mid, which is 0 plus 8 by, so that will be 4. So actually it's present at the mid. Then we are checking. So here it should say true and it will come out. Is found is our value. Yes, this one. We are changing it to true and we are saying break. Break means come out of this. Is found should be true and it should say found it. Okay. Good one. We will do debugging. Tomorrow we will do debug. So in that way, we will learn about the debugging of the program also. Right? Line by line, we will check where is the problem in the logic. So when there is a problem in the logic, yeah, 56, somebody is saying 56 found it, but we are searching for 78. Okay, we are searching for 78, which is present, but still it's saying not found. Okay, that we will check. Don't worry, not a big issue. And in that way, we'll learn about debugging also. Okay, that's it for today. Today's agenda. Thank you, guys.